Hello YouTube, De-bodgery here. Welcome to EV Components Review. This is the Surron Ultra B logic board that we're looking at. And as you can see, it's a giant mess. What I didn't realize is that I was scrubbing this thing with a wire brush, which is right here, is that I was wearing off the tops of some of the components. So like this little IC right here and those two right there, I can't even read those part numbers anymore. And vigorously scrubbing at the potting on here, yeah, literally wore the numbers off the tops of the chip so I can't read them. So anyway, they're parts. That's about all I can really tell you about them. I was really starting to get into the top of the CPU as well, but that one is still readable. But yeah, those two right there and that one, no idea what they say on them anymore. The numbers are nearly completely obliterated. So we're just going to have to guess. I'm going to hazard a guess that that one right there is a CAN bus chip, just because that's probably CAN high and CAN low, and that's a little isolation transformer for it. Yeah, that's a pretty common way that that's done. So that's probably a CAN bus chip, but I can't actually tell you that for a fact because, well, I can't read the part number on it. Anyway, let's start over here on the left and work our way to the right. Okay, so this little guy right here, that is a little N-channel MOSFET, and let me go back to its data sheet. I picked up that one. There she is. So that's an NCEP 02515 power MOSFET N-channel. It's good up to 250 volts and 15 amps. It's not a particularly low internal resistance MOSFET. It's 200 milliohms, which is really, really high. 250 volt parts are usually somewhere like in the 5 to 10 milliohms, not 200 milliohms. So that's pretty crazy high. But you know, this right here is your main DC to DC circuitry. And so that guy is doing basically most of the heavy lifting for that little bit of circuitry. This guy right here, this is the buck chip for all intents and purposes. Let's see, that is a Texas Instruments part. They call it a current mode PWM controller, but another translation for that is a buck chip. Anyway, that is a 2845 buck chip on there, and that's doing the brains of the oscillation and things like that that turns this MOSFET on and off. This is basically just an inductor. I know it looks like a transformer, but it's not. But anyway, yeah, this is your main DC to DC converter from battery pack voltage down to like 12 volts. And then these are both 5 volt linear regulators, so those are V2750 or 4275 A5, so the A5 indicates voltage, and both of them are 5 volts. So one of them is probably for onboard 5 volts, and the other one is for off-board 5 volts. This little package down here, so it says NSI 1200, NSI 1200. That's a little interesting part. So that's from a company called NovaSense, and it is a high reliability reinforced isolated amplifier. No idea what that does. Yeah, reading their product overview, it has a fixed gain of 8 and provides a differential analog output. So, and it has isolation built into it. So I'm not exactly sure what it's doing over in this circuitry right here, but my suspicion is that something about off of the main DC to DC, they need to know this in the CPU somehow. That's my guess. And so they've got this isolated amplifier to isolate the input from the output side. I didn't notice this until just now, but that looks like possibly the pinout for that connector over there. Let's scrape that bad boy off a little bit, see what's underneath there. So, yeah, it's a not super bad shape, mostly readable, but that's probably all the pins for this guy right there. So anybody who wants to get a closer gander of that, feel free. Oops, sorry about that. See if I can't bring that in a little closer. Oh, so I can. This is the new lens which has zoom on it, whereas my old lens that I've been doing for macro stuff, that does not. It's just a fixed focal length macro lens, and this one here, I can adjust the focal length a good bit so I can get in much closer in some regards. So this lens will still not let me get in as close as that macro lens will, but it does have the ability to change the area that I'm looking at by adjusting its zoom and still get in pretty close. All right, so this little guy right here, I did find that part number, as much as it's nearly smudged off the part. Anyway, give me half a second what that one was. Oh yeah, that's right. So that's just an LM293. It's just a dual op-amp package, nothing particularly special about it. Yeah, you probably can't read the number on there. But it actually does say LM293 on there. Yeah, you can kind of see the 2 and the 9. If you hold it in the light just right, it's not scrubbed away enough so that you can't see the part number on it. Yeah, this potting is just an absolute pain in the neck to get off of everything. It just does not come up easy. You know, here I am, you know, scraping at it with the spooger, and it does come up, but it just adheres to everything. It's just a royal pain in the neck. Yeah, just to get the board to this state was a lot of effort. I hope I never have to work on an Ultra B controller because damn. All right, so here is a 3-peak TP2412, and I looked up that guy too. Give me a second here. There she is. So that is a low noise CMOS op-amp package. Single, dual, and quad rail-to-rail output. This is the single. I'm sorry. This is the dual rail version, since this is the 12 version. So the TP241 or 2411 is the single op-amp package. The 2412 is the dual op-amp package, and the 2414 is the quad package. So anyway, this is the dual op-amp version of this thing. Up here, so that's another LM293. So same little guy as that is right there, just not quite so badly worn away from vigorous scrubbing with a wire brush. But again, just a little op-amp package, nothing particularly special. All right, so this one here, so this is an LM239, and that's just a quad op-amp package. Both of these parts are extremely available from a bunch of different sources. You know, I found the TI data sheet for both of these, but you know, these are I don't know what brand that is. I don't see a logo on that thing. Yeah, God, I hate this potting. Didn't dissolve for anything, didn't come off or anything, just sticks to everything. What a mess. All right, this little part right here is pretty hard to read, but there is actually a part number on there. It's a CD4048, and that is a CMOS multifunction expandable 8-input gate. It's just a logic device, or logic chip, and it's got and, nor, NAND, you know, gates inside it. So it's kind of a decision tree chip of sorts, in my opinion. You know, you can put different inputs on the thing and it'll give you different logic outputs on it. All right, so these two chips right here are the same. I don't know if you can read the number on there or not, but they're by 3-peak, and they are 7742s, and that's a 4-channel enhanced high-performance digital isolator. So they've got capacitive isolation, I think, inside them. I don't see it in the data sheet what it says is inside there, but they're good up to 5,000 volts isolation. They can handle 150 megabits per second data rate. I have no idea why you need 2 of these things, but the way it appears to me is the way they are placed is they isolate the CPU from all the gate drive stuff, which is on the other side of this chip, these 2 chips. So I think that's what they are about, is they're making sure that all the gate drive electronics cannot go backwards and zap the CPU. But anyway, yeah, you've got 2 of these things on here, and each one of them is 4 channels each. So that's a little bit of overkill because you only have basically 6 channels, so I'm guessing 2 channels out of one of these isn't getting used for anything. And like you see how these outputs all have this 100 ohm resistor. This one over here, you have two 100 ohm resistors. I'm guessing that fourth output right there is probably not getting used. Because otherwise it would have two resistors on it like that does. So you only need 6 outputs here for the high side and low side gate drivers on any particular motor controller. So yeah, this other output on here is just swinging in the wind or whatever, pulled to ground or something. Anyway, isolated digital circuits, that basically just isolate the CPU from all of the high power side. This little guy right here, no idea what that says. Let me zoom it out just a skosh so I'll have an easier time focusing. There we go. Yeah, as you can see, the top of the chip is pretty well scrubbed off. Yeah, there's nothing there left to read. Just some smudges of some numbers. Yeah, I used a 35x loop over top of that little chip, and I have no idea what it says. It's mostly gone. Okay, so this CPU right here, we'll just move on to the next part. So this is and it's an S32K CPU, and they come in a bunch of different versions, but this one specifically is the SK32-142, and they come in a 116, 118, 142, 142W, 144, and this defines certain details like how much flash, how much RAM, things like they have in them. But anyway, this little guy, it looks extremely similar package-wise. In fact, same pin out, same size package as like the STM32F405, but internally it's lacking some important details like RAM, flash, CPU power, things like that. So it's got a lot less capability despite having the same size package as a much more vulnerable package from VESC, or that VESC would use. So anyway, seemed kind of cool at the time, but yeah, not really as good as I hoped it was. So over here, yeah, I forgot to look up this part number. Oops. Anyway, I'm pretty darn sure this is a CAN bus chip. This one right here, no idea. Probably some kind of an op amp, I'm guessing. That's obviously an isolation transformer, and those two wires right there, so it'd be TX and RX out of this CAN bus chip, go right to it and come out the other side. So yeah, that's very, very, very likely to be CAN bus. Yeah, you can see this little cap right here that I mangled while depotting everything, and all the scratches and everything. That's from sharp implements poking at potting. Yeah, everywhere you see all the scratches where the solder resist is gone, yeah, that's from me poking at stuff to get rid of potting. Yeah, this board was super not easy to depot, and it's still covered with crap. I definitely don't like leaving things this dirty when I depot them. That is still an absolute flaming mess. So you can see all these little guys right here. These are all TVS diodes. They're protecting basically inputs into the controller from over voltages, so that you have a safer input coming from the outside world before it gets over to the CPU. Yeah, we've got some more TVSs over here for that purpose as well. Yep. All right, what else do we got here to look at? Obviously, this is one of the current loops. No idea how good or bad these things are. Don't see a part number on them of any kind. The little hull is going to be right there. It's all encased inside this plastic, so I can't really look at it and see what part number it is. Let's scrape that up, see what that says underneath there. Yeah, this potting is just a pain in the neck. Yep, I hope I never see another Ultra B controller ever again. Anyway, there you go. So SD08PF072A2, version 1.03 from September 5th, 2022. Yeah, and here is an Ultra B controller. So anyway, that's the top side of the board. Nothing really else major to look at. That's a little opto isolator package. Not sure what that does. Probably something with CAN bus, maybe. In other words, the output. Well, no, that's an isolation transformer. We don't really need opto isolation on that. I don't know what that would be for. Something else, obviously. Just don't know what. I still think that's probably the programming port for the CPU. Ugh, yeah. Oh, the potting. That probably goes inside and over to a couple programming pins on there. But I don't really know that. And yeah, no idea what was supposed to be at IC8. Yeah, you can see this stuff comes off. It's just that you have to like scrape at everything to get it off. Otherwise it adheres really well. Yeah, I mean, it does come off. And I'm pushing pretty hard with my spooger to get this stuff to come loose. It's just a royal pain in the neck. I can't stand this potting. It's, you know, you can see it's really grainy looking. And it just adheres to everything. I haven't found anything that makes this stuff dissolve. So somebody has some ideas of what might make this crap go away. That'd be super cool, because I tried everything I could think of to make it go away. Yeah, grr. Definitely don't like leaving boards this messy. Okay, so I think that's probably everything here to show. Let's look at the bottom side. There's not a whole lot here to see. So we flip it around. There we go. So here is the connectors. Yeah, those are surprisingly clean. I mean, that is surprisingly clean, considering how everything here was just all caked up with potting. Yeah, then there's still plenty of it in between the pins that I didn't get. Yeah, this stuff is just, yuck. Worst possible potting I could come up with. Yeah, you can see up here, this is your ground right here. And this RF shield, there's a definite gap between the battery minus plane and here. Yeah, it doesn't connect up to that in any way. Here's the other battery minus plane. Same thing. It doesn't connect up to this RF shield. So I'm not sure how they do that. Maybe there is like a capacitor and resistor or something like that on the board that connects to here through some inner traces or something. I don't know. Or it's just a completely floating RF plane. That's a very good possibility too. Anyway, that's the logic board. I think I'm going to stop there, and on the next video I'll deal with the power stage.